Right.
Although it'll take a second for the channel to catch up. There we go. As per usual, wait for people to come in. Last week of Gameathon, or not Gameathon, that was the last one. Last week of the Unity Bit Camp. Exciting stuff.
Is there something after this where they're like showing their final presentations?
Yeah, but we'll be checking in with mentors and whatnot to gauge progress, and if need be, we'll push it back by a week.
Okay. Oh, so it's like scheduled for next week?
Yeah, for next week, unless it isn't.
All right. Something to look forward to.
Mm-hmm. We'll just wait 30 seconds. The main thing, like usual, is getting the recording, so I think it's fine to not wait too long. To the people just tuning in, hey, welcome back. This is the last week of our multi-week Unity educational series, our Unity Bit Camp.
Yeah, this is week 7. We're going to go over particle systems. Again, I'm Chris. I'm from Brandeis University, president of VR and Game Dev Club there, and today we're going to be going over particle systems. So particle systems are essentially ways of displaying objects that you wouldn't normally be able to display with like a 3D mesh. So we're talking things like explosions, we're talking things like fog, heat distortion, and this is stuff in games that you can't really represent with like triangles. And particle systems do this in a very interesting way. They use a ton of atomic units that each have their own transform, and transform being like their own position, velocity, and acceleration. And by utilizing all of those atomic units together, they can create something dynamic and something very, very interesting. So to start off here, to create a particle system, you go in the hierarchy of your scene, you create an empty object, and in the inspector, you click Add Component, and you search up Particle System, and you click the component that is there. All right, before I forget, this tutorial is going to be using the same starter code as last week. It doesn't matter if you've done the audio portion yet or not. It's none of the particle system stuff that we're going to be doing in this tutorial is going to be dependent on the audio stuff. That would be pretty cool. All right, so it looks like, yeah, let's just set this stuff back to normal. So this is what a particle system looks like. As you can see, it's made up of these atomic units that each have their own path. So one good way to sort of analyze what a particle system is doing is to follow a single atom all the way until it reaches its limit and kind of analyze the pattern it's going in. Before we do that, though, there's sort of a red flag here. Everything's pink, and usually when something's pink in Unity or purple, that means a texture is missing, and you need to assign a material. So to do that in a particle system, you scroll all the way down to the bottom, open the submenu called Renderer, and fill in this material. So this would be particle, and you're looking for something called default particle material. Either of these is fine. I sort of prefer this one. And we get an image that looks sort of like snow, and this is much easier to analyze. All right, so as I was saying, if you want to analyze a particle system, you follow one of the atoms and you see what it's doing. So for each of these, you have a singular image, and it's going in a straight line off into the horizon until it eventually disappears after a set number of seconds. And all of these individual atoms, yeah, they all have a different starting velocity. And in combining the simple motion and creating multiple particles and emitting all of these particles with that same motion, we get something very, very interesting. And this is just the default particle system. So a particle system is just like it's very different from components that you're used to, but but it also looks sort of the same, at least this first part. So we have some familiar stuff like public variables in which you can input numbers, you can click check marks like booleans, and you can select things from menus, and these would be enums. Before we dive into this, there is this really, really helpful particle effect menu here. And this allows you to pause a simulation, play it again, restart it from the beginning where no particles have been emitted just yet, and also to hide the particle system if you don't want to see it, and restart it again. If it's going too fast for you, you can set the playback speed to something slower. If something cool happened and you want to rewind, you can set the actual playback time to sometime in the past, from the beginning, and even way into the future. Resimulate. This will allow your particle system to be updated whenever you make changes here, so keep that checked on. Show bounds. This is helpful for like understanding like where the furthest particle is going to be, and it's helpful when you're moving things around. And these two options, simulate layers and show only selected, those are kind of useful when you have multiple particle systems, so we won't really get too deeply into that. All right, so what does this component do? There are a lot of things that we can change in this component to change like the nature of this particle system. But here, duration, this is how long a particle system is going to last. So this is counteracted by this looping variable. And this looping variable is just saying, okay, well, like emit things forever. But if I were to turn this off and restart the simulation, it starts emitting for 1, 2, 3, 4, 5 seconds, and then it stops. All right, I'm going to keep it on looping for now on, but that's just what duration does. You can change the actual character of the particles with things like start speed, start lifetime, start size. And these sort of all do what you kind of expect them to do. If you change the size, they grow bigger. If you change speed, they go faster or slower. If you change lifetime, they're going to last longer. Or you can make them die early. And rotation, well, that's just going to, it's going to be a little bit difficult to see with the circles, but here, you can see like sort of the guide markers that yes, these particles are rotating. All right. Color, also a fun option. Let's change these particles to red. Gravity, also very fun. We can have these particles obey the laws of physics or go anti-gravity. What else is there? I think that's mostly it. Max particles is something helpful to be aware of. Like if you're emitting like a ton of particles at a time, this will set a hard limit on how many particles can be on the screen at a given point in time. So if I set this to 10, only 10 particles can be emitted. And when these particles die off, new ones will be emitted, as we'll see in just a sec. There we go. All right. This was 1,000 before. Anything else? Yeah, I think that's all you sort of I think that's all you sort of need to get started with particle systems. That's all the basics. One thing that you might be interested in is all these arrows on the side, and these are very important once you get into the more complicated stuff down there. So when I was like adjusting all this, all I had to do was input a number, and that would be a constant. But particle systems are a lot more flexible than that. We can say I can do a random between two constants. So when a particle is spawned, it can either be a size of 1, or it can be anywhere from 1 to 5. So here you see there are bigger particles and there are smaller particles. And this is a very, very nice soothing effect. Another thing you can do, curve. And it'll start at 5, but you can set this curve to change what a particle looks like over time. So x-axis would be time, y-axis would be size, and when you start from the beginning, they start off really, really big, but as you follow a particle during its lifetime, or, oh, no, not a particle during its lifetime, but over the duration of the particle system. So over time, the particles being emitted are getting smaller and smaller. All right. And the last one is random between two curves. This is the most complicated one. So a particle, over the duration of the time that the particle system is being emitted, it starts off being 0, but it can be any random value between these two curves. Again, x-axis is the duration of how long the particle system has been going for, and the y-axis would be the size. And the particles can be anywhere along the spectrum. There is another way to there's another way to edit these curves, or another window, where called the particle system editor, where you can like maximize this window, edit the curves to better precision. But for the most part, I'm just going to be keeping it in the inspector because it's useful to like be able to conveniently see what the particle systems are doing and what you're doing on the side here. So I'm just going to X this out. All right, that's basically the basics of particle systems. If you just like play with all these settings, you're going to go pretty far. But there's still so much more to it, and we'll get into that once we get into the prototype scene. All right, so the prototype scene is going to be the same one that we used from last week. And again, I'll go over a brief overview for those of you who are just here for the particles. So let's just rotate this to a better view. All right, so when I press play, I'm going to play a construction worker. This is a 3D-esque game, but we can only move in one direction. And I need to press space to jump over obstacles, and when I hit an obstacle, I die. Let's see that again in action. I am a construction worker. I am trying to jump over traffic cones. The world is infinite, or so it seems. And when I bump into one, I die. So there are a couple things that are going on here that I won't go into the particle systems. Those of you from last week might remember. The construction worker has animations tied to him, and those animations are controlled by Unity's internal animator. The animator is a finite state machine, which means that only one animation can be playing at a time, and you can only get to certain animations from certain animations. So for example, I can be in a running state, and I can only go to a walking state from the running state, and I can switch between walking and running. And the triggers for those transitions you define through code. Another aspect of this game, the infinite traffic cones coming. Are these called traffic cones, or are they called something else? I'm just going to call them traffic cones. And the background that is looping infinitely. So how the traffic cones are being spawned would be in the spawn manager script that I have put on the traffic cones, or a game object spawning them. And they are called using this invoke repeating method. Invoke repeating will call the spawn obstacle method once every couple seconds. And once an obstacle is spawned, it will move left on its own because we have another script that does that. Last thing to go over is the background. How is it that the background is repeating forever? Well, we don't have an infinite sprite. We have something called illusion. So in order to best see this, I'm going to disable some stuff on the player that I'll have to redo later. I'm going to disable the box collider, make him kinematic, and make him not use gravity so that the collision between him and the traffic cones isn't going to be registered. So he's not going to die while I'm not looking at him. And in the scene, you can see the player is stationary, but the background, it's moving left, but when it hits a certain point, it resets to its original position. And if we go back to the game, we see that this transition is basically seamless. So those are that's an important point to note, that the player is stationary. And when we put a particle system on that player, that'll be a small point to keep in mind. All right, let's restore him to his former physics-based glory. I think it's checkmark. Don't checkmark. All right, so our goal for this scene is going to be to put in a dirt particle into the scene and make it look like he's kicking up dirt as he runs. And the second is to have some sort of representation of his soul leaving his body when he bumps into an obstacle. So we're going to have an explosion particle like that. We're not actually going to make these particles from scratch. This project actually had 2 effects that you can navigate to with course library particles. And we have 2 ready-made particle systems here. So yeah, we'll have to edit some of these later to kind of fit our needs. But for now, let's take a look. All right, let's zoom in. This is the dirt splatter. It's going a little bit fast to sort of analyze, so remember what we said. You can change the playback speed to be as slow as you want. Looks like there are these little cubes flying out, and if I look at an individual one of these cubes, it looks like it's following some sort of straight or slightly affected by gravity path. And these cubes are getting smaller over time, which is something that we didn't see with the particle system when we were just playing with the standard options. They're also slightly rotating over time, some of them, I believe, and they're all coming out at different velocities. All right, so let's take a look at what is going on here. We have several of these modules that we didn't have checkmarked earlier. That is velocity over lifetime, rotation over lifetime, color over lifetime, which is, can you see that? It's not super obvious, but it is there. And it is these modules that give it this more complex behavior. All right, so putting this in the scene is easy enough. This is what it looks like in real time. So when a particle system is set to play on awake, it's going to automatically play regardless of whether you instantiated it with the script or not. It's just going to be there. So this is actually super obvious. Since our player is not actually moving, we can just put this dirt particle under the player somewhere between his feet, like so. And just like that, we have a particle system playing in our game. That was easy enough, just like drag and drop, put it in the scene. Let's see how it looks. Yeah, not bad. Although a problem with this is when I'm jumping up in the air, the particle system's still playing, and when I die, it still looks like he's kicking up dirt. That's not good, but I'll teach you guys how to fix that. All right, the next one we are going to examine is the FX explosion smoke. So we are going to play this when he falls over. Let's move it to a better place. All right, so nothing's happening with this particle system, and that is because, well, it already did its thing and we didn't see it. And this is unlike other particle systems that sort of emit particles continuously. This one emitted all of its particles at once and then stopped. So I'm going to click restart, and you're going to see this blocky explosion. So what made it do that? Well, I'll get into that in a bit, but for now, I'm going to check on looping, restart here, and then we'll just see that this blocky explosion is just going to be playing over and over again. You can see the particles are going crazy, so it's going to be like emitting semi-irregularly, but that should be fine. So what are each of these individual particles doing? Well, let's take a look. One of these particles is emitted from the bottom. It has like a certain downward velocity at first, but then it floats up into the sky. And I think that's a hallmark of anti-gravity. It looks like this particle system has anti-gravity turned on. The size, just like the dirt particles, is slowly disappearing as we move on. And they all continue for a while before they eventually become really, really small and disappear. All right. So what exactly is going on with the system? Well, first I'm going to just tell you about why it behaves the way it does when looping isn't turned on. It's because its emission is of a burst type. It only emits once at time t equals 1 second, 0.1 seconds, and 100 particles are emitted, and it emitted with a 100% probability. So in this short duration of 0.5 seconds, it was only able to burst once. And if you don't have play on awake, when you have play on awake, it's just going to burst, and that'll be the end of the particle system. All right. So how are we going to place this particle system in our scene and have it play when at the proper time? Well, let's first move it into the proper place. This should be sort of in the middle of our construction worker. Like so. And now we need some way to play this particle system through script without enabling this play on awake function. We don't want the explosion playing like as soon as we start our scene. The way we do this is through the player controller script. Yours might look slightly different from mine if you've done audio. I've just reset everything. And, well, we just do a component reference. Let's make a public particle system. We can reference a particle system just like any other component. And let's call this explosion particle. And when it, oh, I'm in the wrong script. Do not put this in the spawn manager. Make sure nothing weird's going on here. All right, public particle system explosion particle. We're going to put this in our player controller script so we can access it through there. And there is a special part in the script that triggers when we hit an obstacle, and that would be in here, in on collision enter. When we collide with a traffic cone, it's going to register a collision. It's going to compare the tag with ground, and it's not going to be the ground. It's going to set game over to true. It's going to do all the stuff that's associated with crashing into something and ending the game. So these two are animations that trigger the death animation. So this is exactly where we want to put our next line of code, which will be explosion particle dot play. All right, that was 2 lines of code. And let's see what that did. Save. Return to Unity. Remember, we did that component reference, so we're going to have to go into the player and then drag the explosion smoke into the field. So here, we drag the explosion smoke into the player controller field. It now has a reference to that explosion smoke, and we can call the .play method on that explosion smoke when we hit an object. Let's see if it works. Jump. Die. All right, it played. It didn't look very appealing. One, the explosion particles were just too big, and we couldn't really see what was going on. And there are a couple of other changes that I want to make to this particle system. So let's start simple. What is this going to look like from the beginning? Well, the first complaint I had about it was, well, the size was too big. So let's go to the start size. Instead of a random number between 0 and 1, I'm going to say a random number between 1 and 0.15. And that looks a lot better. I also think the particles are going a little bit too fast, so that would be start speed. I'm actually going to set the velocity to 0 because anti-gravity will do its own thing, and the particles had an initial velocity to begin with. All right, start lifetime. I think the particles last for a little bit too long after they've faded off, so I'm going to say rather than between 4 to 6, maybe 1 to 2. And that's pretty much all the changes I personally would make. Of course, you might disagree with my opinion. You would make your own changes here and come up with a different particle system. So let's play this simulation again. And that's sort of more what I was going for. So to recap, to change some general effects of this particle system, I went into the particle system component. I went into this sort of its standard component stuff, changed some key values, start lifetime, speed, and size, and I got something different. Let's hit play and see what the changes look like. All right, it triggered twice because the collision happened twice, and we have a small bug in our game that allows us to die in midair. But let's see that again. All right, that's a little bit better. All right, so now that we got the basics down, I kind of want to introduce you to all of this other stuff in the particle system. The two most common or most important parts of the particle system, aside from this main section here, would be emission and shape. So to observe a little bit better, let's keep this particle system looping once again and play it. All right, so emission. We talked about this a little bit, but the reason why the particle system behaves the way it does is because this one is set to a burst. So at one point in time, it's going to spawn 100 particles at once. Other things that we can do, rate over time, maybe 5 particles per second. Rate over distance, depending on how far the game object travels, it's going to, a particle is going to be emitted. Like you can imagine, that would be really helpful for if you had a car and you wanted smoke coming out from behind it. And yeah, right here, this emission, if I turn it off, nothing's going to happen. No particles are going to be emitted. So this is where all of the magic happens. The second is shape, and making changes to this part of the particle system isn't actually going to do all that much in most cases, but it's sort of important to understand what this section sort of means. So it means that within this box area, all of the particles are being emitted only from this area. They're not being emitted from anywhere else. And this doesn't have to be a box. We can set it to like a donut, like a torus, an actual mesh if I had one, circle. And yes, this doesn't really make too much of a difference in how it looks, but it does play a part in like how much variance there is, I suppose. We can also set it so that the particles only come from within the box. from the outside surface of the box or just the edges of the box. And you can make some really cool effects if you change these two values and you know what you're doing. All right, that's shape. So how about all of this other interesting stuff? Well, I guess I divide all these separate modules into lifetime modules, speed modules, and all this extra stuff down here. So what do the lifetime modules look like? Well, instead of changing the character of the particles over the duration of the particle system, we can have them change. We can have the character of the particles change as they go up. So in this example, it looks like the size over lifetime, the particles are getting smaller and smaller over time. And the reason behind that is because we have a curve here. And the curve says, okay, start at a very high speed and gradually slow down. Or start at a very high size and gradually get smaller. Velocity over lifetime looks similar. We have X, Y, and Z. And this is a random between two curves, actually. So a particle system can start at any of these two velocities or anywhere between these two velocities, and slowly they're going to converge to this point, which is 0. So they're gradually going to slow down. And not considering gravity. Limit velocity over lifetime. This just limits how fast the particles can go. Color over lifetime. This isn't super easy to see, but yeah, you see that the particles start off darker, and when they're super tiny, they become white. Maybe a better way to illustrate this is, well, when you're editing color over time, you're going to get this window like this. To edit the gradient, you want to click on one of these values and set it to any color you wish. I want it to start out red. And you can click on one of these. And instead of clear, I want to set it to a nice blue. So what this means is it's going to start out red. Over time, as the particle fades off into the distance and disappears, it's gradually going to turn blue. All right, how does this look? It's got this real cool technical. It's got this real cool techno effect. So I really like color over lifetime. Color by speed is an alternate option. You can change the color of a particle based on how fast it's moving. We went over size over lifetime, rotation over lifetime. It's super, super hard to see, but each of these particles is rotating a little bit. And all it's saying is put an angular velocity into some of these particles so that they are consistently rotating over their lifetimes. And rotation by speed, same thing for speed. All right, so that's, I believe, all of the lifetime and speed modules. Now let's look at some of the more interesting stuff. Noise. This one is going to add some random variation to how the particles are moving. So if I click this on, this might really lag my computer. It's going to apply the noise to all of the particles. I did it anyway. All right, so there's a little bit more random variation. It looks a little bit more wavy. And this is perfect for weather and like snow. The default particle system looks like snow to begin with, so you can just turn on the noise, and then it looks like wind sort of blowing these particles. There are some options here. You can set the strength of the noise, this here, preview of the noise. It's sort of how strong the particles are going to be affected, and the particles all kind of lie in this space. So let's see, strength 2, maybe. Yeah, now it's really, really windy out here. I don't want to mess too much with the noise right now because it's sort of slowing down my computer. But other things here, you can change the variation of the noise, make it not so coherent. You can have the noise change over time. So that's really fun. Ooh, another fun thing, collision. What is it set to right now? Planes. Okay, that's good. So what this means is I can define a couple of planes in my scene. And these planes are going to be collision detectors for these particles. All right, so I am going to create an empty object. Let's get back to our explosion. Where am I? Collision. All right, let's set this game object transform to here. And as you can see, this generated a plane where the game object was, and none of the particles are getting through there. It is also possible to have particles collide with anything in your world. All you'd have to do is set this option to world, but this is very resource intensive. Like, you gotta check for like thousands of particles, like whether they're colliding with something in your world. So planes is the more popular option, and you just make a bunch of these. All right, that's collision. Next would be, we don't really need to talk about this stuff just yet. Light's useful if you like your lighting is really good and you want to have like glowing particles like circle your room. Trails is super, super interesting. So for this, I'm just going to slow down the playback speed a bit, and I'm going to turn on trails. All right, so here you can see the path of each of the particles as they fly up into the sky. And this is another great way to analyze like what a particle system is doing. Again, we're getting that pink texture. Again, remember, this is a red flag. We need a material for these trails. It's not such a big deal now, but if you wanted to do that, you'd go to trail material down here in the renderer, and you'd select something nice like, let's say, this concrete wall. And now our trails are gray. And that looks really, really cool. All right, so we had a lot of fun playing with velocity over lifetime. Color over lifetime is really the biggest change I made. The rest is sort of left on its own, but yeah, let's see how the game looks now. Running, nice dirt trail, jump. We still have that problem with a dirt trail, but if we can play a particle animation, we can also stop it. All right. Okay, that's really nice. The reason why I played multiple times is because I still have it set to looping. All right, let's turn that off. All right, so we're almost done. Let's just fix that issue with the dirt particles, and we'll be all set with the prototype scene. In player controller, let's make another public particle system called dirt particle. All right, this gives us a reference to our dirt particle. And what is it that we wanted to do? We wanted to have it stop when we're in the air, and we also wanted it to stop when we die. So when we die, that's easy enough. We can just say dirt particle dot stop. And when we're in the air, that would be here. When we're every frame is checking if we press space, and then if we press space, it's going to trigger our jumping animations. So here we are going to say dirt particle dot stop again. And finally, we don't want them to stop indefinitely whenever we jump up into the air. So when we're on the ground again, we're just going to play the dirt particle once again. Simple 3 lines of code, just inside each of our critical conditionals. 4 lines of code if you count the component reference. And just wait a little bit. And so once you tie these particle playing and stops to critical conditionals of your program, then you have mastery of particle systems. Unassigned reference exception means that the changes I made don't make any sense because I did not put the dirt splatter inside our player controller. Let's look at that again. Dirt particle playing when I jump. Okay, when I die, it's still going. This is unexpected. Let's see if there was anything wrong with my code. Okay, so if I jump up in the air, it stops. Dirt particle.play, dirt particle.stop. Let's clear the console. This small detail like not working isn't such a big deal, but this is the way that you get particle systems to stop. As you can see, when we are jumping, the dirt particle is not emitting anymore, and when we die, it is also not emitting. So this is a gigantic success. We have successfully implemented particle systems in our game and made it look about 2 times cooler. All right, now I'd like to show you some more complicated examples of particle systems. Here we've kind of confined ourselves to sort of cubic particle systems. They aren't really all that complicated. They're 2D. So Unity has something called the Unity Particle Pack. It's free for download, and I have it in my version of the scene. I didn't put it on your guys' version because that would just make the project too big, but I figured I would show you here. So when you download the particle pack, you'll see a new scene in your project folder called main. Let's actually not save our changes to this. And well, it has a sample scene, and well, it's an empty airport right now, but as you'll soon see. We're in an explosion playground. And this is just the coolest stuff. So it's not immediately obvious how you get to this from all of the particle system I've showed you. But trust me, all of this stuff was made purely using the particle system, and there were there was some extra stuff that they put on top of that. All right. Wildfire Explosions. Computer's lagging a bit, but that's okay. Fireflies. I really like this one. You can see like the individual ones buzzing. Teleport effect, dissolve effect, sparks, candles. You can sprint in the skin. Muzzle flash. Goop is really interesting. You can actually make this with everything I've showed you so far. Like the liquid coming out of the wall. And it's just a bunch of particles just like playing over and over. My computer is lagging out of its mind right now. But here, icicle attack, magma attack. And yeah, it's not immediately obvious like where the particles are in some of these. And that's really because some of these are using something called the texture sprite animation or sprite sheet. However that's called in the actual particle system. So when you see something like this rising steam, it's not actually a bunch of tiny, tiny particles rising up into the sky. It's actually a bunch of 2D images. So this is something that you got to kind of wrap your head around. When you see an effect like this in a game, it's not actually 3D. It's a bunch of 2D images, and they're just being broadcast to you in a way that looks like it's 3D. So if you look really, really closely at the bottom of this steam, you'll see that there is a line that's perpendicular to how I'm looking at it. And that kind of marks the bottom of where the 2D image starts. If I go around it, you'll see that this line stays perpendicular to me. So it's just a bunch of 2D images that are cleverly facing me. And I guess it's more accurate to call them 2D videos because they're changing over time. This one, I think this is a prime example of, oh, I still have a way to go. Like when I press a button on my computer, it like continues going for so long, it's like I'm drunk. All right. So we have a rocket ship, and we have particles being emitted as it's going up. So this is a great example of particles being on a global scale rather than a local scale and being emitted from one place. And it takes a lovely hike into the sky and disappears as a little star. All right. And if I can safely navigate my way to, okay, let's stop this nonsense. All right, let's see if playing again writes things. All right, I'm feeling decent. All right, let's go to one of these explosions over here. Let's actually go for this one. Oh no. Hang in there. All right. So each of the particles that you see in this scene, since we're in the Unity editor, we can inspect any one of them and see what's really going on. So if I select my player, press F, focus, we get directly to him, and we can select any one of these particles and see what the magic behind them actually is. That is a wall. Shockwave. All right, yeah, big explosion. This would be this particle system over here. All right, so what's going on? There are multiple particle systems at work actually here. So this one, the big explosion, this is the red and orange stuff that you see flying out from the center. Light, I think that's just the orange glare that you see like against the walls. The embers, these are the little floaty things. All right, additional smoke. This is all the black stuff you see after the explosion. It's behaving slightly differently. Shockwave, this is a little bit hard to see, but you saw there was a little bit of a distortion here. That's the shockwave. And debris, this would be the little pieces of flying chunk. All right. So let's kind of break this particle system down a little bit. It's so hard to navigate. All right, you can see it decently from here. So let's turn off the light. Once we turn off the light, it's like a very, very cold explosion. If we turn off the embers, then there's nothing flying out. And let's turn off the smoke, the shockwave, and the debris. And this is what we get left out of this is what I mean by like this 2D, is that all explosions are really just 2D. All explosions that look like this. So let's look here at texture sheet animation. That's what it's called. Here, you see that you see some interesting stuff like mode, grid. Okay, so there's a grid involved. There's a frame over time, so it's playing like a movie, and over time, it's changing its frames. It looks like this is just a linear interpolation. Start frame, what frame it's starting in. So it really, it really is a movie. You're starting from a certain frame. You're changing those frames to make it look like it's moving. And yeah, so this texture sheet animation is really doing all the heavy lifting inside this particle system. So if I turn it off, what'll happen? All right, that is not what happened when I ran the game before. Let's see what happens in the game view. All right, it's not gonna show its true colors just yet. But texture sheet animation. Oh, I'm looking at additional smoke. Now let's look at big explosion. Texture sheet animation. Let's turn it off. This is what you're actually looking at. This is something called a sprite sheet. So if you want to take a look at that sprite sheet, you'll see it down here. Explosion, shader, particles. Maybe it's in the renderer. Yeah, right here. If you look at this explosion, it is an 8x8 or 6x6 grid of images. And essentially what it's doing is it's playing these images one after the other as a 2D image, and it's showing it to you, and it's always facing you, so it gives the illusion that it's 3D. When I turn the style sheet off, it's not looping through any of these. It just assumes that this image as shown is supposed to be what the particle system is playing. All right, I'm not going to spend too long fawning over how cool these explosions look. So if you have, this is really fun. If you get the chance, please download the Unity Particle Pack. Take a look at each of the particles. Not all of them are like the style sheet, but a good deal of them are. And yeah, hopefully you'll find something fun in that. All right. And before I forget, let's move on to the homework. I'm really all done with my lecture now. So here, not that window. So what particles systems really are on like a technical level is just this particle system component, and you're memorizing, or you kind of come up with these values that sort of make the particle system look best. And if you can get those values, like the size over lifetime, start size, etc., and you get that for a certain particle system, you've essentially got the particle system. You've got the explosion in your hand. And so I think the best way to think about this is as particle systems as sort of recipes. So if you want this particular particle system, which I've termed the red nexus, this is a bunch of trails and some noise combined together to give this really cool eldritch effect. This is really just a bunch of these numbers. In particle system, I set start lifetime from 2 to 5, and so on and so on. I added some noise, I added some trails, and I gave it some default materials. So you don't have to like make a recipe sheet like this. This is just a useful way to think about particle system. If you want embers, you do all of this. And if you want an explosion, then you need this material, the specialized material that you need to put a texture sheet animation on. So with all that in mind, your homework this week is to go to a YouTube tutorial, try to follow the steps one by one, all of the values that they're putting in, try to put in on your computer, and try to recreate their particle system exactly. Alternatively, you can download the Unity Particle Pack and look at one of the particle systems and sort of reverse engineer it and come up with something new based off of that. Maybe not for the texture sheet styled particle systems, but maybe for like the goop effect, and maybe for the embers. And in whichever game you're starting to build, put this particle system in that game and make it look really cool. All right, that's all for me. Yeah, have fun with this. Have fun exploding things.
All right, Chris, thanks so much. So for the rest of you guys, you're going to be keep on working on your final projects. We'll check in with mentors as soon as possible to let you know to figure out whether or not we're going to be presenting either next week or the week after that. But yeah, thanks so much, guys. See you.